Welcome to Lecture 8. This is the first lecture of Unit 2. You did it! Unit 1 is over. But it's not over. Don't forget that stuff. That's the foundations that we're going to use for the rest of this course. Now, we're going to kick off Lecture at 1 and we're going to talk about something called membrane potentials. I want to start off Lecture at 1 by talking about this man, and his name is Tony Robbins. And he is an inspirational speaker, a life coach. And interestingly, he was one of my first introductions to physiology, believe it or not. And I feel some of these quotes are fitting for us. Success is buried on the other side of frustration. And a lot of his quotes called to me because for me, I am a low-income student and I spend hours working, about 60 hours a week, trying to put myself through college and not being able to have the luxury of taking time off to study to be successful in school. So I spent a lot of time in school just buried and just getting tests back, fail. And it was really difficult for me to see that all of the failures were growth. But back to Tony Robbins, I was bartending. I had 2 jobs and one of them was bartending. And I remember commuting an hour-ish to my bar and then driving back to my apartment and then being just so keyed up because, now I'm like working late at night and I'm now a night owl and not being able to sleep. And I had one of these old tiny TVs that had the rabbit ears because I didn't have money for cable, but I could catch infomercials at about 3:00 in the morning. And that's what I used to watch to settle myself down in order to fall asleep by 4:00. And for months, Tony Robbins was running his infomercials and he was talking about how what we eat is so important because it charges our cells. Okay. And he said, if you eat a cucumber, and I like meat. If you eat a cucumber, Tony Robbins says, it has so much more voltage and energy in it that it will give you more energy. And when I was listening to that after a night at the bar, I was like, this is such boo hockey. Cucumber isn't going to give me as much energy as a double whopper. There's no way. Okay. And so I just laughed at Tony Robbins because I thought he was ridiculous. But as time went on, guess what I did? Because I was curious. Guess what I did? I measured. This is my father's voltmeter, okay? And so here, what you folks are seeing and what we'll be doing, this unit is measuring a lot of volts. And so here you can see that if this little orange line moves, then I'm measuring voltage. So what did I do? I went and got me a cucumber. And oh my God, Becky's, look, it actually changed. There's voltage in here and I could measure it with this voltmeter. And I was like, what? And so what did I do next? You see here? Okay, so what I did next was I went and got some meat. And I didn't have burger, but I had chicken. And I stuck the voltmeter in here. And did it move? It moved a little bit. But if I put the 2 pictures side by side, right? So this is the cucumber voltage. And then this is the chicken voltage. The cucumber voltage did move more. And I was astonished. And I was like, oh my God. Tony Robbins, you were right. All right, now, what does this all mean? I'll tell you. What the voltmeter was picking up was something called membrane potential. And what a membrane potential is a difference in charge between outside of the cell and inside of the cell. So what I've drawn for you folks here is lipid bilayer, okay? And now we're talking about charge, right? So outside of the cell, you're going to have a whole bunch of differently charged molecules. Some are going to be positive, some are going to be negative, right? So in your mind, think about what are positively charged molecules. Sodium, calcium, yes? Chloride is a negatively charged molecule. So we know that we have these ions all over our body, inside and outside of the cell. Now, remember from Unit 1, that we have a disequilibrium, right? We have a difference in charge. So there's something that the cell does to allow us to have a net negative charge inside of the cell and a net positive charge on the outside of the cell. And what this cell now has done with its differences in charges, we have now created a battery. Yes, so if you folks don't remember what a battery is, you can look it up online. Not everybody uses batteries nowadays, but go look at the battery, right? And you'll see drawn on the battery, there is a positive end and there's a negative end. Our cells now, with this net difference in charge inside and outside of the cell plasma membrane, we've now created a battery. Okay, this is what we call chemical and electrical disequilibrium. Okay, so words are important. When you see disequilibrium, this means not in equilibrium. And what does that mean? Equilibrium means we have the same amount of positive ions outside and inside. Same thing with the negative ions, right? So if a cell is in equilibrium, there's no charge difference, okay? The cell's charge would be neutral. But instead, we have a charge, and this charge allows us to do work. Now, in order to have a difference in charge, we have to have compartments. You folks remember compartments? Okay, it's because now with the plasma membrane, it can be a boundary where I can now move some positive ions on one side and negative ions on the other. Okay, and that allows us now to have this chemical electrical disequilibrium. So this should not be new to you. This should be what we call old hat review. Okay, so this is all Unit 1 stuff. And if you folks look at this graph on the y-axis, this is all my ions, right? Yes, right here. And then on the x-axis, this is telling me where I'm measuring these ions. And these are different compartments inside of the cell, outside of the cell, plasma of blood, okay? And they all have different potentials based on what these areas are trying to accomplish. Now we have to ask ourselves, how is it that the cell is able to have differences in concentration of molecules inside and outside of the cell, right? That's the mechanism. So what is the mechanism behind electrical disequilibrium? And you folks already know that answer, right? Is this sodium-potassium pump. And this sodium-potassium pump allows us now to have this disequilibrium of sodium and potassium inside and outside of the cell. And this is going to play an important role about how the cell now can function as a battery. And that's what we're going to start to discuss in lecture at 2.